So it seems I got a little rusty over the summer, and I didn't do the greatest job on my time management on Friday for our very first lesson, but I will get better at that. But to fix that mistake, we did have to kind of flip this since I'm not there. But now I really am there because I am going to finish off, or I am really here. Welcome to my house to finish off this lesson on 2.1 functions. So the first thing that I want to do is just kind of review what we started on Friday, and that was comparing and contrasting functions versus equations, and what we did find was there wasn't a very big difference at all. You're still working with input and output values, but we just have this special notation for functions that we're using that says, hey, for every input there is only one output. And that's the only condition that makes functions a little bit apart from equations, but otherwise every function is an equation. So let me actually just illustrate that real quick. We have this world full of equations, right? And we have different things that we're going to be writing up for various situations. So we're trying to model various situations with math equations. But there are, within these equations, what we call functions, because we know those equations have a very predictable type of outcome because every input has only one outcome. So all functions are equations. Just let's keep that straight. So we use this function notation. It looks something like this, where you are expecting an output given an input. Alright, and then finally, this is the part we did not really get to. We have to use methods to recognize a relationship or an equation, this could also be equation, as an actual function. Okay? So quick review. Eventually we are going to be fitting data and coming up with equations, or functions, I should say functions, for that data. And we went through all of this. Quick, remember all this? Yeah? Requirements, there is only one output for every input. We said linear equations are always functions. Linear equations are the most basic function we have. It's just a line. And here's my wonderful little cartoon. The x's can't be doing any of this stuff. Okay, because then they're cheating and it's not functional. Okay, so this is where we got to. So this is kind of one method. I'll just call it method 1. Of determining if function. So what we call it is the vertical line test. And what you're going to do, if you need to pause me, go ahead and pause me, but you're going to graph or plot the relationship that they give you, and then draw a vertical line through it. If it is a function, then it's only going to pass one time. So if it crosses more than once, we have some equations that look like this. So for example, I'm just going to give y equals, and then let's say we have the square root, and then plus minus x, I'm going to say negative x plus 3. Alright, that's going to look something like this. Okay, it's not the best sketch. Okay, but if you were to run a vertical line through this, what you can see here is no, this is not a function because these vertical lines are touching the graph more than once. This would be one of those scenarios where you would say, well, what happens if you plug in 1 to this equation? And what would happen is you would have 2 different answers, which would be weird. So this is not a function. Okay, versus if you had a linear equation, something like y equals x plus 1, something like that. Oops, I missed my dots, but you can kind of see it. Linear equation, if you pass a vertical line through that, you're seeing that for every input there's only one output. So this is, yes, a function. So that is the vertical line test. But do note you're going to have to graph it, or if you don't know what the equation looks like, you will have to do an XY table and plot it up. Did I mention linear equations are always functions? Because they are. Gotta remember that. Alright, so example number 30, use the vertical line test to determine whether this relationship is a function. So again, there is an equation behind this. You don't know it yet. You'll eventually learn it. But all they're asking you to do is look at this type of equation that must have put these plot points on this graph, and they're asking you to run that vertical line through it, and you can see right here, no, it is not a function. Not a function. Alright, so we also, I'm going to call this method to function. Whether it's a function, is it? Yes. Is it? No. So question mark. So we have these input tables, that's this right here, and we also have set diagrams, that's this right here. I'm not a big fan of the set diagrams, but you'll see it if you read through your book in 2.1, they do use this as an example. So set diagrams are just where you have your input values and then you have your output values, and they'll have to mark that somehow to you. So here I've done that by saying here's my domain, which are all the input values. That's in your definitions from Friday. And here's my range, which are all the output values. So this is that input set, this is that output set. So the idea would be that as you look through this, you have to make sure that there's no weird kind of inputs that are producing two outputs. So this -1 here is creating a problem for us. So this would not be a function, so no function here. And if this is still confusing to you, and it's that idea that we have a cheat in x, it's not functional, so that's going back to that cartoon. But you could also set up an XY table for this, and this XY input-output table is the same thing as the set diagram. So you'll see over here you have the -2 linked to 3. You have this -1 linked to 3, but that -1 linked to 4. In an input-output table, you should never have a duplicate input, because that input then is going to these different outputs, and that's not okay. And then finally, if these still don't make sense to you, what you could always do is draw a graph, and then you could do your vertical line test. So I'm going to go ahead and do that real quick here. So -2 up 3, and then we had -1 up 3, and then we had -1 up 4, and honestly right there you could call it quits, because what just happened was this would not pass our vertical line test. Alright, so there's kind of method number 2. If you ever do get data represented to you in either one of these two ways, you should be able to look for that you're only, for every input there's only one output. Alright, this is another example directly from your input, or homework. Sorry. So you're going to graph the function y equals 4x. So note how they said graph the function, and then they labeled it y. I'm going to go ahead and say I'm going to stamp this as f of x instead, because now we know exactly that there is only, for every input there's only one output. So that right there, that's all it does. So you could look at it like this. There's nothing wrong with that, but this just makes it a little bit more specific to a mathematician who knows the notation. So because we discussed that a function is just an equation, you can use your same old graphing techniques. So here's x, and normally we would call this y, but I'm going to call it f of x, just so we can start working with that notation. And so then what you can do is really, you can, if you recognize this as a line, you can go ahead and use line techniques to graph that. But otherwise here I'm going to have negative, I'm going to just plot some points. If it were -1, it'd be -4. If it was 0, it's going to be 0. If it was 1, you're going to plug in 1. So what's f of 1? Well, we're going to have 4 times 1, because we're saying input for that variable x, 1. That's what that's saying, so we're having 4. And that, because I know it's a line, honestly I only needed 2 points, but I'm going to go ahead and I'm going to graph this. So always at least give me this scale value, but otherwise, here we're going to go back 1, down 4, 0, 0 is a plot point, and 1, 4. So there is a line of slope 4, and then it goes right through our origin. So again, functions are just equations, so we can use x, y, or input-output tables to plot and then graph. That's what number 6 was all about. Did I mention linear equations are always functions? Did I? Okay. Alright, evaluating functions at specific values of the independent variables. So decide whether the function is linear, evaluate the function. So again, what you are looking for is it fitting that y equals mx plus b format? So where m and b are a number. So let's go ahead and look at 43. I'm going to say yes. Here you might question that there's no m, but there is technically m. You could put a 1 there, and we fit this linear equation precisely. If you wanted to, you could always graph it too and see does it make a line, and what you would find is it would. So yes, it is linear, and when you evaluate this at this given value, so again, this notation is just saying input 4. Wherever you have an input variable, they're saying put 4 in it. So f of 4 would then be equal to 1 times 4 minus 11, which is going to get us -7. That's it. So f of 4 is equal to -7. If you were to put that on an xy table or an f of x table, input output, you would have 4, -7. That's what that's saying. This one's kind of weird. You would look at it and say, hey, there's no m, there's no x even, so what is this? So this is where I would suggest maybe you should start plotting some values. So let's start with actually evaluating this. If I were to plug in -4 into this function, what would I get? Well, there is no input place, so all we can assume is this is just going to be 2. So regardless of whether I plugged in anything, it's always going to be equaling 2. So this function is equal to 2. Let's plug in another one. I could plug in 0 if I wanted, but there's no place to plug it in, so it's just 2. If you were to start plotting what this looks like on a graph, so -4 up 2, 0, 2, what's happening here is there's just always going to be a 2 value. This is a line. We'll talk about this more. But this is just a horizontal line, so what you can say is, yeah, it's linear, it's forming a line. The xy table would look something like this, no matter what, and it looked similar to just y equals 2 if you recognize that equation from the past. But if you plugged in -4, you would get 2. If you plugged in 0, you would get 2 because they're saying this function or the y value is always equal to 2. So there you have it. So this is the practice set. We will not be going over this until Thursday. Do note that you are getting the answer keys to these. Again, I need to repeat, use them wisely because the answers themselves are not important. It's the process and really understanding. So I hope that I'm kind of doing a perspective shift by giving you those answers. You start to see that, and you'll know that you need to ask the questions in order to understand. It's not so much the answer I care about and getting this just done. It's the asking questions so that you gain understanding. Good luck on it. We'll collect these on Thursday.